2.6, graphs of basic functions. A function is continuous over an interval if there are no missing values of the domain. In other words, it's continuous if you can trace the graph without lifting your pencil. So the one on the right, the W shape, I can just trace from left to right, the whole thing from left to right without tracing. So this is continuous. But the graph on the other side, if I was going to trace, when I get right here, there's a hole. I'm going to have to pick up my pencil and jump over that hole to get to the other side. And so that's not continuous. At that point. So the question says, describe the intervals of continuity. Well, the one on the right, it's continuous the whole way. So it's continuous from negative infinity to positive infinity. But the one on the left, it's got two pieces. The left side of that hole, that's going from negative infinity to 0. Put parentheses to signify that it doesn't equal that number right there. Now we've got the right side. Okay, the right side is going to be from 0 to positive infinity. And again, you use parentheses to show that it's not equal to. Only other thing you need is a U in the middle. That U stands for union, and that means we're going to join those two pieces or those two sets. Zoom this out a little bit. Here you see the graphs of 6 different parent functions. You've got a linear function and a quadratic, a parabola. You've got a cubic. You've got an absolute value, a square root, and a cube root graph. Those 6 are pretty important, and you want to just have those memorized. One thing that's going to come up in one of your assignments is the linear function is called the identity function. They're just going to ask a question that says something like, which of these is the identity function? But the identity function is just that line. It's y equals x. And how you can think of it is a number is going to keep its identity. So think about if you plug in a number like 47. If you plug in 47 for x, 47 is going to come out for y. That number retains its identity. That's the identity function. So mainly just memorize the shapes and what they look like. Now we get into piecewise. Students really struggle with piecewise, but you really have to pay attention and just think about where it's talking you or it's telling you to look. Okay. Most people that struggle don't really look at that second part of the function. So when we do f of 6, remember that 6 is an x number. And so what it's telling you is to look over here, and when you see 6 is greater than or equal 1, that means you're going to use this bottom piece. So all you do is take that 6 and plug it in. 4 minus 6 is negative 2. I know to use the bottom piece of that piecewise function because 6 is greater than or equal 1. When you look at the other problem, negative 5, I can see that negative 5 is less than 1. So that tells me to use the top piece of the function. I have 2 times my number plus 4. We're plugging in negative 5. So that's negative 10 plus 4. We get negative 6. F of negative 5 equals negative 6. Then we're going to graph. Okay, we're going to graph this piecewise function. One thing to keep in mind is it has to pass the vertical line test. So make sure of that. Now, let's look at this piece individually. 2x plus 4. If I was going to graph that, I'd start at 4, and I'd go up 2 and over 1, and up 2 and over 1, and I'd have a line that looks something like this. Now, you don't want to draw that whole thing in yet, because we're not going to have that whole thing. We're only going to have a piece of it. And that's where that interval comes in. X is less than 1 is like the domain. And so if you think about the domain, look at the x-axis. X is less than 1 is like an open circle on 1 and an arrow left. So if you squashed my graph down onto the x-axis, it's going to look like that. It's got to be x is less than 1. You're only looking at those x values. So basically what I want to do is get rid of everything on the right side and only keep this part of that function. Now we're going to do the other part of the function, the other piece of the function, 4 minus x. I'm going to switch that around to negative x plus 4 because most people are better graphing that way. If I start at plus 4 and go down 1 and right 1 and down 1 and right 1 and down 1 and right 1, I'm going to have a line that looks like this. Now you can tell that can't be right because this doesn't pass the vertical line test. So that's not a function. I've got way too much. I haven't considered my domain. X is greater than or equal 1 says, really, I only want from 1 to infinity. And so I've got extra pieces of that graph that shouldn't be there. I only want to start it at 1. So remember where that line was. It was like right here is where it started at 1. And then the line continued here. So now a couple things, if you think about it, if we squash that whole thing down, red and blue is going to pass the vertical line test, but it's also going to cover all real numbers on the domain. So the domain of that function is all real numbers. It's not continuous. It jumps over at x equals 1. You're going to have to jump your pencil. But it does pass the vertical line test, so it is a function.